right, today we're working out of the Big Ideas book. In lieu of a final, we are going to finish up Chapter 5 this week, and I am actually going to go into Chapter 7 and teach you factoring so that you can practice factoring over the winter break. You will need to know the factoring techniques. You will need to be able to factor like you know your... Don't worry about it. Nope. You will need to be able to factor like you know your multiplication tables. You will need that for when we come back. So we're going to have a chapter wrap up, a quiz this week, and a chapter test, and then we're going to start factoring right away. Yeah. All right. Tonight you're doing 5-6, and we are skipping section 5-5 for this chapter. Will not be responsible for that. All right. When given the inequality, x is less than or equal to 3, when we put that on the number line, how would I go about graphing that on the number line? Kate? It would be a solid dot starting at 3. In which direction would it go in? Towards the negatives or to the left, okay? What does that solid dot mean? Let's go with John.
That 3 is included in the set.
3 is included in the solution set. So that means anything less than 3, including 3, is included in the solution set. When we are graphing on a coordinate plane, we do things a little bit different. I want you to first, we're going to make a boundary line, and we're going to turn our inequality temporarily into an equation. X equals 3. And what was the work that I had you show when you had an equation with one variable? Yes. What kind of work did we show?
You have to make a table.
Make a table.
And set all x values to 3. And
Set all x values to 3. And how do I get my y's?
just choose any.
Choose any y. So I'm going to choose -1, 0, and 1. And then I plot those points. 1, 2, 3, -1. 1, 2, 3, 0. 1, 2, 3, and 1. Are there any questions? And then we would draw our line. We can tell it's a vertical line. Okay, but when it's an inequality, it means any x is less than 3. So that could be like this point. What's that point? That's -1, 2. Would that satisfy this inequality?
No. Oh, really?
Yeah, because -1 is smaller than 3. So you've got all this whole area. And so one thing that I like to do is I look at my axis. On my x-axis, okay, this is like a number line. Here's 1, here's 2, here's 3, 4, 0, 1. Okay, where are the numbers less than 3 on the x-axis? Where are the numbers less than 3 on the x-axis, Chris?
They're the ones to the left.
To the left. And so that would be the area that I would show that I have to shade in. Over here is all the solutions to that inequality. It's not just one, it's that entire area would satisfy. I'm going to erase this and just show you how they do it because it looks so much neater. There's my boundary line. Oops. And now I'm shading to the left. Okay, are there any questions? All right, let's try it again. If I do y is greater than -2 on my number line. Now I want you to notice something on the last problem. You will notice that on the number line at 3, it's solid because it includes 3. When the line is solid, it's inclusive of all those points on that line. So let's take a look at the next one, which is not. All right, so let's go on to the y is greater than. And so what are we going to do when we graph it on the number line? What's it going to look like? Gabby?
An open circle.
An open circle at -2 going in what direction?
In the right direction.
To the right. Now, if it's open, what does that mean? What does that mean, Zach?
Which is not included in
It's not included in the solution set. -2 is not included in the solution set. So we have to show that on the coordinate plane how it's not inclusive as well. Now again, we're doing the same thing. We're making ourselves a table. X and a Y. And this time, what's constant? What's constant, Jack?
What's constant is the
Y. And so what am I placing for the Y? That's going to be constant. Did you write the last problem?
Yeah.
Okay, so what am I putting that's constant here?
that y is
Always. And how do I get my X's, Jack?
is you pick 0, -1, and 1.
Do I have to? Can't I pick like 3? I choose whatever I want for my X's, but my Y's have to be a constant of -2. So I do 0, -2. -1, -2. And we get the idea that this is what kind of 1, 2, 3, -2. It's what kind of line? All right. It's horizontal, right? So now, the difference here is it's not inclusive. Does anybody know what we put with an inequality? Caleb?
We put a dotted line.
A dashed line. So you just make it dashed. And what that means is everything up to, but make it dashed. Okay, now, I come back up here and notice it says y is greater than -2. I go to my y-axis this time. Okay? Here's 0, here's 1, here's, oh, that's -1, that's -3, here's -4, here's 1. Where are the numbers greater than -2 on the y-axis? Chris? Not Chris, Ian?
Everything above the.
Everything above the y-intercept there. That whole area is now what gets shaded. Are there any questions? All right, we're moving on. Yes, I understand. No, I don't. Any questions? Yes? Okay. All right, so now let's go to just a linear equation in slope-intercept form. The first thing you're going to do is we have to create a boundary line. Remember, we just turn it into an equation. And I always, always, always want you to identify 4 things. Your M, you write the equation, we identify your M, we identify the B, because table method takes too long. So let's graph using slope-intercept. What's my M? What's my B? -1. Okay, is this going to be solid or dashed? Solid. And then I want you to tell me if we're going to shade up or down. Does anybody know? Nicole?
Down.
Shade down. Just, you can even write down. You don't even need shade down. As long as you're just jotting these down. So, I'm starting at -1, and I'm rising 2, running 1, 2, 3. Rising 2, run 1, 2, 3. Rising 2, okay, I forget. How about negative 2, 1, negative 1, 2, 3, left. Negative 2, 1, 2, 3. And then, did we say it's going to be solid? Okay, so I'm going to give myself a nice solid line. And then, now I have to deal with the shading. Now here's my little method. I get rid of the slope in the y-intercept and I ignore it temporarily. And I read it. Y is less than or equal to negative 1. Where are the numbers on the y-axis less than or equal to negative 1? Above or below this point? John? Below. This is negative 2, negative 3, negative 4. Here's 0, 1, 2. So what I do is I just look at this. Y is less than negative 1 on the y-axis. The number is less than negative 1 on the y-axis is below that point of intersection. So that whole side is the area that gets shaded. Does that make sense? I really shouldn't put two colors. Questions? Okay, there is a second method. And the second method is the test point. We can choose any point, Julian. Any point. Any point. Let's make it easy. The origin, 0, 0. And we plug it into the inequality. And we make a judgment based on whether it's a true statement or a false statement when we simplify it. So when we simplify this, what does it become? Hike?
0 is less than or equal to negative 1.
Good. 0 is less than or equal to negative 1. Is that a true statement or a false statement?
False.
False. So at this point, that means when it's false, we shade the opposite boundary area. If it's true, I would shade that side. Since it's false, I go to the other side of the line and I shade in that area. When it's false, I go to the opposite side of where the test point is. Nicole.
So if it was a vertical line, would you do the same?
If it was a vertical line, I mean, I'm generally just kind of looking at where it crosses on the intersection. You could take a test point. But all you're really testing is the x value. Does that make sense? Now, it includes every point on the line. Questions? All right. Now, since it's false, I shade in the area, not where the test point is. So, if you want to write this down, pause the recording. And just a reminder, we shade up when it's greater than, but it's solid if it's equal to. And it's dashed if it's just greater than or less than. So remember, we shade down if the less than is touching the y. But I just kind of tend to make sense of it as opposed to going back and using this chart. So pause it if you want to take. Okay. So again, what am I going to do first? Step 1. Andranik?
Find the M and B.
Good. My M is, always write the equation. M is what?
Negative 1.
My B is?
3.
Good. Okay. Will it be solid or dashed?
Solid.
Why do you say dashed and he says solid? What makes it solid? What makes it dashed, Andranik?
So it's dashed when there's no sign.
Right. Is there an equal sign?
No.
So is it
Dash.
dashed? Stop playing with that. Okay. Will we shade up or down based on what's touching the Y?
Up.
Shading up. Okay, so I'm plotting it. I start at 3. Make sure that you're doing, remember, it's down 1, right 1. We only take the negative in the numerator or denominator, not both. And rise over run to your next few points. We can take the negative in the denominator and go up 1 to the left 1. And Andranik said it's going to be dashed. And he said we are shading above. Now, I want you to remember, I go to my y-intercept right here. Oops. I go right here, and I say to myself, y is greater than, I block that out, 3. Where are the numbers greater than 3? They're all here, so that's the area that gets shaded. If I did my test point, it basically works the same way. Because if I take 0, 0, the origin, is 0, 0 the only one I can do?
No.
I can take any point. But 0, 0 is good because it just blocks something out. 0 is greater than 3. Is that a true statement?
No.
So my 0, 0 should not be shaded. Questions? Yes, Nicole.
In the homework, will it give it to us as a... Oh, yeah, that's what I was going to ask.
No, of course they're not going to give it to you pretty and perfect looking. You have to get it alone and get the y alone, and we're going to be graphing. Okay? So what do we do first? Yeah, why don't you start it?
Okay, get the y alone by
Subtract
subtracting 4x.
4x.
And then you divide by 5.
Divide all terms by 5. My m is negative 4/5. My b is 2. I start at the 2. I rise negative 4, run 5. Rise positive 4, run negative 5. Is the line solid or dashed? Solid or dashed, everybody? Am I, go back to your slope-intercept form. Are we shading up or down? Everybody. Because, remember I take the, get rid of the mx or add a 0, 0. And so it says y is greater than or equal to 2. Here's my 2. Where are the numbers on the number line on the y-axis greater? Over here, so this whole area is shaded. Questions? Okay, couple things to look out for. Couple things to look out for. Step 1, what am I doing? Audrey?
Get one on
Okay.
So you subtract 3x.
Subtracting 3x. And now?
Divide by negative 2.
Divide all terms by negative 2. And what do we have to watch out for? Zach?
You have to reverse the inequality.
Why? Why?
Because you're dividing by negative.
When we divide by a negative on an inequality, remember we flipped the inequality sign?
Yes.
Who's awake and hears me? Thank you. Okay. So we have to flip that inequality when we divide by a negative and do all the same thing. Okay, questions? Okay, a couple other kinds of questions, and I'm rushing kind of through this. Pause the recording, and then you can check your work. Once you pause the recording, you can try the next problem. Let's look at... Don't be freaked out on this equation. Remember, just get y alone. Move your y to the other side. If y is touching the greater side, then move the greater side of the inequality next to it. Flip it around. Solve for y, get y alone. What's my m? What's my b? Yep. My b is 0, so don't be afraid of it. All right. Now, the next type of problem that you will have is something like this. Don't be, confused by my PowerPoint that shows a graph. There's no graphing. It doesn't say graph, McRitchie, so you don't have to graph. It says determine whether the point is a solution. You don't get to just write yes or no. You have to prove it. You substitute the point into the inequality. If it's a true statement, it's a solution. If it's a false statement, is negative 13 less than 9? So this is a solution to the system. Yes.
First, do you need to correct it?
You don't have to. I just said that. Because the directions don't tell me. Just substitute the point in. Notice on the next one as I substitute in. Is 9 less than 9? True or false statement? So is this a solution? Not a solution. You have to say that. You don't get to just say not a solution. You have to prove it and then make the statement. Hike.
They give you the point, right?
Yeah, they'll give you the point and say, is this a solution to the system? Now, the last part is to write the inequality. You work backwards. Step 1, make the table. Okay, that's a Y. Okay, pick 3 points. Boom, boom, boom. 0 across, negative 1. 1 across, negative 1. 2 across, negative 1. Write the equation. What's constant, guys? Y equals negative 1. Now, convert this to an inequality. It's shaded above or below. So how am I going to show that? Y is less than negative 1. Do I put the bar underneath it? Because it's dashed and box your answer. Okay, what do we need to write the equation here? Ben. And? Good. And the B is what?
The B is 4.
And the y-intercept? And the slope? Count it. Rise 2, run 1. Stop. Freeze. Recording. So what is the equation? Shh.
Y equals 2x plus 4.
Please freeze. Okay. Now we got to set the inequality sign. Look at the intercept. Is it less than or greater than? The number's less than 4 or greater than? So we are doing y is less than. Because it's solid, I have to do the equal sign. 2x plus 4. And that's it.